So in this session, we will see about an Josephus problem. Josephus problem is nothing but it's an application of a linked list. Application of linked list, we have seen different types of linked list: single linked list, circular, double circular, all those things. And Josephus problem is an application of circular linked list. So it is like a game. Suppose there are a group of people are there, a group of people, around 5 people are there. Then the 5 people are standing in a circle. So then we will say the skip number as here 2. Okay. So now what happens over here? Every second person will be keep on killed. Okay. So 1, 2, the second person will be gets killed. 3 and 4, the fourth person will be gets killed. And then 5 and 1, the first person will be get killed. So only 5 people are there. So only 5 people are there means what? The count starts from the first number onwards. So if 1 and second person gets killed, and 3 and fourth person gets killed, and 5 and 1. The one is gets killed, and then 3 and 5. 5 gets killed. Only 3 is remainder. So 3 is the winner of this logic. Josephus problem. So now what happens over here? Circular linked list. So what happens over here? So deletion is happening. Deletion is happening. Okay, the link will be gets reallocated, and then the deletion will keep on happening. So now, for example, if we will take one example, there are 5 people are there. The skip count is 3. That means that every third person will be gets eliminated. Every third person will be get killed. So now in a circle they are standing 1, 2, 3, 4, 5 by order. So from starting count from 1. So 1, 2, 3. The third person gets killed. So the remaining people in the circle are 1, 2, 4, 5. So now after 3, what's the next number? 4. So 4, 5 and 1. So the third person in the from the fourth onwards, 1 is the person. So deleted the 1. The remaining persons are 2, 4, 5. So resume from the 2. So 2, 4, 5. Eliminate the 5. And then resume from the where you have left. After 5, 2 is the number, right? So 2, 4 and 2. That we have eliminated the 2. So the remaining person is 4. So he is a survivor of this problem. Okay, when we take skip count as a 3, then he is a survivor. Okay, so now for this logic, we need to write a code. We need to write a code. For this logic, we need to write a code. So how do we do it? Okay, so now what we'll do is, so now here you can see an example where here each node have a data and then address. Data and address. Okay, so the first node, okay, for example, let me take this as here first node and second node and third and fourth. Okay, so the data and 002 is the address of an next node, and then data 0030 is address of an next node, and then 003C is address of an corresponding next node, and then 002C, it should be 002C, it should be points to go towards this node. So for this logic, we should write a coding. Okay. So now here, this is a subprogram. Okay, it's a separate module for the survivor. So in the main program, we will ask the user what is the skip count. What is the skip count they want to. So here they will give the skip count value as a 3, and then how many people are there in the circle. They'll give it as a 5. Okay, we will get from this user, and then we will call the subprogram as survivor. So this program will be gets called up. So now here struct node, we have used double stack head. So what does it mean? Okay, it's a pointer to a struct node, because there itself there will be one pointer will be gets called out, and here also we are going to use a pointer. So where we can change the head pointer over here, That's the meaning of double star symbol. Okay. So and then here we have an corresponding local variable star pointer as a P and Q, where P is nothing but the initialized first pointer, the initialized pointer of a Q. Okay. So for example, this node address, this is the first node. So this node address is in the P, and then the Q will be the previous node of P. Q will be previous node of P. So initially the both will be okay. The both will be assigned to the head. Both will be assigned to the head. Then we go by step, always P points to the current node and then Q points to the previous node of P. So where will delete? I will delete the current node. I will delete the current node and then I will resume from the Q onwards. Okay, so I have an I variable for the purpose of traversing in the linked list. Okay, so now here what I'm going to do it over here is I will the P is assigned, so we will be loop. We'll go for a loop purpose. So while P of next is not equal to P, while P of next is not equal to P. So that what does it mean here? So until only one node is there, then only it will go for P of next is will be equal to P. So for example, P, I have data here over here. The P will be assigned to the first node. Okay, the P of next 002C. Okay, 002C. And then what happens over here? It will goes to this node. Okay, so if you have only one node, then what happens over here? The address will be address of the first node itself. So until that happens, it will keep on traversing. Okay, so while P of next is not equal to P, I'll be keep on doing the deletion of nodes. So once P of next is equal to P, that means that there is only one node is available. So he is a survivor of this problem. Okay, so I have used for loop over here. So for I is equal to 0, I less than k minus 1. So where k is the number of person to be skipped. So in our case, we have taken k as a 3. We have taken k as a 3. So now here for I is equal to 0, I less than k minus 1, I increments. So for loop. So now what happens over here? I is equal to 0. For I is equal to 0 initial, the q will be assigned to the p. Q will be assigned to the P. So now, for example, the P address is something called 1000. So now Q is assigned with the 1000 address, and then P will be P is equal to P of next. So P is assigned to the next node. So okay, P will be equal to 2000. So here we have 5 nodes are there. Okay, the first node address is 1000, second node is 2000, third node 3000, fourth node 4000, fifth node 5000. We will remember like this. Okay, first node 1000, second node 2000, third node 3000, fourth node 4000, fifth node 5000. This is the address of each node. So now here, so initially what happens over here? P is equal to head. Okay, so 1000. So Q is equal to P. So we have assigned that Q is equal to 1000 and P is unupdated to the current node. Current node. So you can see here P is 2000 and Q is the previous node of the current node. Previous node of the current node. So then what happens to the same for loop? So I is equal to 1 node. I is equal to 1. So where 1 is lesser than the 2. Okay, this condition satisfied. So I goes inside the loop. So now Q is equal to P. So Q becomes 2000 and P is equal to P of next. So P of 2000 next is 3000 address. 3000 address. 3000. So then what happens over here? This loop gets failed. Okay, I increments. So once it increments 2 lesser than the 2. No, it's not. So this loop gets failed. So once this loop gets failed, then what do I do it over here? So I should delete the corresponding third node. I should delete the corresponding third node. So for that, what I'm going to do it over here is Q of next. So Q of next is equal to P of next. So in the Q of next position, okay, in the queue is 2000. In the 2000 node, the next position is 3000, right? So I should delete that node. I should delete that node. So what I'm going to do here, I will place the address of 3000 of next. I will place address of 3000 of next. So now what happens over here? The P of next is 4000. So now here the Q of next is assigned with the value called 4000. 4000. So now what happens over here? We have removed the P from the list. The 3000 has been removed from the list. So now once we have removed the list, removed the P from the list, then what happens over here? Whatever in the 3000 we have number, right? We have some number called 3. That person has been killed. And then free the memory space, free the memory space of P. So 3000 memory space has been freed up, and then P is assigned with the new value. P is assigned with the new value. Thus P is equal to Q of next. What's the Q of next? Is the value is 4000. So P is assigned with the 4000. P is assigned with the 4000. So then what happens over here? The while loop will keep on continues. So now P is 4000. So now I'll check for 4000 of next is not equal to P. Okay, obviously there are 4000 of next is going to 5000. It's not equal to 4000. Okay, so now what happens over here? Once again, this loop continues. Once again, 4, 5, and first will be gets deleted. Okay, and then 2, 4, and 5 will be gets deleted. So like it will keep on going. It will keep on going. So at one point, P of next will be equal to P. So that's the point. It's a conclusion that the only one node is left. Only one node is left. So I will and update the head. So P is assigned to the head, and then I'll return the P of number. Okay, where nothing but head is the address. Head is the address. So in the P of number question, okay, the number is the which has been surveyed, which data has been surveyed. The data will be given back to the main program. So this is how the Josephus problem has been solved. Okay, so a simple one. So initially we have declared an we have declared with subprogram. So here we have used a double star head. That means that we have pointed to a pointer of a struct node. Okay, so where we can change the head over here also. And then we have declared a two pointer called P and Q for traversing purpose, and I is for loop. So P is assigned with the head, and then Q also is equal to P. So that means both are same. Both Q and P are same value head. So always P is the current node and Q is the previous node of P. So until while P of next is not equal to P. So when what is survivor? Only one node is there, that is called survivor. So when P of next is equal to P, that means that with the same address. Okay, the P of next is we have same address, that means that there's only one node available. So until then, I'll be keep on deleting the nodes. So for the purpose, I have used for loop. In the for, we have used k. K is a skip count. So k is skip count. It can be any value by the user. It can be from the user. Any value can be from the user. So in our case, we have taken 3. So we have 5 nodes. In the 5 nodes, each node address starts from 1000, 2000, 3000, 4000, 5000. So every third node will be gets deleted. So at first, 1000, 2000, 3000, 3000 node gets deleted, and then 4, 5000 gets deleted, and then 2000, 4000, 5000 gets deleted, and then 2, 4, 2000 gets deleted. Only the last one is 4000. So the 4000 of data will be given back to the main program. So it will indicates that the survivor of this circle of 5 data is going to be 4 as a survivor. So this is the problem of Josephus, which is application of a single linked list. Thank you.